Okay. Hello, good morning, students. Today we are having our Maths 101 class again. The topic we are looking at this morning is polynomial. And as you can see it displayed, we'll first of all be looking at the definition of a polynomial and now other properties of a polynomial. We said that a polynomial represented at P of S is equals to a subscript n raised to power n plus a subscript n minus 1 x raised to power n plus n minus 1 till you get to a raised to power a raised to 0 x raised to power 0. That is what we call a polynomial function. And under it, you see some examples of a polynomial given unto us, that P of S equals to 3s plus 1 is an example of a polynomial. This is a polynomial of degree 1. Number 2, we have P of S equals to 2x raised to power 2 minus 5x plus 3. The highest power there is 2, which shows that that is a polynomial of degree 2. And number 3, we have P of S equals to x raised to power 3 minus 2x raised to power 2 plus 3s minus 1, a polynomial of degree 3. And the last one is P of S equals to 12 plus 2x squared minus x raised to power 4, polynomial of degree 4. So we'll go ahead now by letting you know that we have what we call a monomial. It is a type of a polynomial that has only one term. An example there is P of S equals to 2x raised to power 3. It has only one term. The other one again is what we call the degree of a polynomial. The highest power of x in the polynomial is called the degree. Example is P of S equals to x raised to power 3 minus 2x squared plus 3s minus 1. It's a polynomial of degree 3 because the highest power there is 3, which you have on x, that is x raised to power 3. Now, the coefficient of the term with the highest power of s is called the leading coefficient. Now, like the example given to us under it, P of S equals to 12 plus 2x squared minus x raised to power 4. In this case, the highest power there is 4. The coefficient of that x raised to power 4 is minus 1. So that is why we say that the leading coefficient is minus 1. A polynomial whose leading coefficient is equals to 1 is called a monic polynomial. The leading coefficient is equals to 1 is called a monic polynomial. Now we have P of S equals to s cubed minus 2s squared plus 3s minus 1. In this case, or in this polynomial, you see that s cubed, which has the highest power, is having a coefficient of 1. So in that case, the given polynomial is a monic what? Polynomial. If all the coefficients of a polynomial are equals to 0, we said that such a polynomial is called a zero polynomial. So we are trying to go through all this so that when we are using all these terms, you know the meaning of all that the term, or you know the meaning of the terms that are being used. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic. A polynomial of degree 3 is called a cubic polynomial, while a polynomial of degree 4 is called a quadratic polynomial. Now, we can perform algebraic processes, basic algebraic processes as far as polynomial is concerned. And what do we mean by that? These basic algebraic processes entails addition, subtraction, multiplication, and division, which shows that in a given polynomial or polynomials, you can be asked to add, you can be asked to subtract, you can also be asked to multiply, and you are also asked to what? Divide the given polynomials. Now let's go straight to the first one, addition. When you have a polynomial P of x, the example there, equals to 2x raised to power 4 plus 3x raised to power 3 minus 11x squared plus x minus 6. I have a polynomial of q of s, which is 2x raised to power 3 plus 20x squared minus 3s plus 8. We are asked to add p of x plus q of x will give us 2x raised to power 4 plus 3s raised to power 3 minus 11s squared plus s minus 6 plus 2x raised to power 3 plus 20x raised to power 2 minus 3s plus 8. So you see, we only have 2x raised to power 4. And there is no other term in the polynomial q that has the power raised to power what? 4. So in that case, you bring that down, 2x raised to power 4. Now for p of x, you have 3x cubed. While for q of x, you have 2s cubed. So 3s cubed plus 2s cubed will give us 5s cubed. In polynomial p of x, you have minus 11s squared. While in q of x, you have plus 20s squared. So minus 11s squared plus 20s squared will give us plus 9s squared. Again, plus x plus minus 3s will give us minus 2x. Minus 6 plus 8 will give us plus 2. So p of x plus q of x will give us 2x raised to power 4 plus 5x raised to power 3 plus 9x squared minus 2x plus 2. That is when we add the polynomial p of s and polynomial q of x, that will be our result. So we have another one given to us there. P of s equals to x raised to power 5 plus 3x raised to power 4 plus 2s raised to power 3. Q of s is equals to 2x raised to power 5 minus 4x raised to power 4 minus 3x raised to power 3 plus 2x raised to power 2 minus 7. So we are asked to add p of s and q of s. So you will do that as your DIY. Do it yourself. Now we'll come down to the second one, which is subtraction. Subtraction just simply means the difference between the two given polynomials. Like the example we have before us, p of s is equals to 2s raised to power 4 plus 3s raised to power 3 minus 11s squared plus x minus 6, and q of x is also given there. So we have to find the difference. So 2x raised to power 4 plus 3x raised to power 3 minus 11x squared plus x minus 6 minus the second polynomial, which is q of x. Now, if you look at the polynomial q of x, the x raised to power 4 is missing there. So to represent it in q of s, we now say it's equals to 0x raised to power 4. You know, any number you multiply by 0 is 0. So we have 2x raised to power 4 minus 0x raised to power 4. That will give you 2x raised to power 4. You have 3x raised to power 3 minus 2x raised to power 3. It will give us x raised to power 3, or what 1x raised to power 3, which is the same thing as x raised to power 3. Minus 11x squared minus plus 20x squared. That will give us minus 11x squared minus 20x squared, which is the same thing as minus 31x squared. You have x minus 3x, which will give us x plus 3x, because you have minus times minus, which will now make it to be what? 4x. Minus 6 minus plus 8. Minus times plus will give us minus. So you now have minus 6 minus 8, which will give us minus 14. So p of x minus q of s will give us 2x raised to power 4 plus x raised to power 3 minus 31x squared plus 4x minus 14. Now we have the other second example again. You can also look at that yourself. P of x minus q of x. You do it yourself. Now we come to multiplication. Multiplication, if we have Pn of x that is having degree n, and you have Qm of x that is having degree m, then their product, which is Pn of x times Qn of x, has a degree of m plus what? N. So you should take note of that. Let's look at the first example. Consider the following polynomial. P of s is equals to 6s squared plus 2s minus 3. Q of s is equals to x plus 3. Now we have to find the product. We have to multiply out P of s and Q of s. So we have 6s squared plus 2x minus 3, bracket open and close, x plus 3. So what you do is that you use x in the second bracket to multiply all the terms in the first bracket plus 3 multiplying all the terms in the first bracket. What I'm saying is this: x into 6s squared plus 2s minus 3 plus 3 into 6s squared plus 2s minus 3. So x times 6s squared will give us 6s cubed. S times 2x will give us 2s squared. S times minus 3 will give us minus 3s. We now have 3 times 6s squared, which will give us plus 18s squared. 3 times 2s will give us plus 6. 3 times minus 3 will give us minus 9. So you now simplify for that. 6s cubed plus 2s squared plus 18s squared will give us plus 20s squared. Minus 3x plus 6x will give us 3x. The last term there is minus 9. So the answer, when you multiply P of s and Q of s, it will be 6s cubed plus 20s squared plus 3s minus what? 9. The second example is P of s is equals to s cubed plus 4s squared plus 5, and Q of s is equals to 2s cubed minus 1. Find the product. Do that again at home. We look at the last one in the basic algebraic processes, that is division. In the process of dividing the polynomial P of s and Q of s, we usually arrive at a result of the form P of s divided by Q of s, which is equals to Q small letter x plus R of s divided by Q over s. And in this case, Q of s must not be equal to 0. Because if Q of s is equal to 0, it becomes an undefined expression. In the given expression, P of s is called the dividend. Q of s is called the divisor, while the small letter q of s is called the quotient, and r is called the remainder, and that the degree of q of s is less than or equals to the degree of what? P of s. The process of carrying out this division is called the division algorithm. It's called the division algorithm. You have a theorem there, which don't bother yourself with it. The first step in division algorithm is what we call the long division. The long division has procedure or steps to follow. 1, arrange the term of the polynomial P of s and Q of s in the descending order, which means you start from the one with the highest power to the one with the lowest power or with a constant. Number 2, you divide the first term of the dividend by the first term of the divisor and write the answer directly above the first term of the divisor. Number 3, you multiply the divisor by the quotient and subtract the product from the dividends. Repeat step 2 and 3 until the degree of the remainder is less than the degree of the what? The divisor. Now let's look at the way we now have to express it. After you have taken all those steps, you now write the answer in the form P of s divided by Q of s is equals to Q of s plus R of s divided by Q of s. Let's look at an example now. Divide the polynomial P of s, which is equals to 3s cubed minus 2s squared plus 5s minus 7 by Q of s, which is equals to s squared minus 2. Now let's look at the procedure. In applying the long division method, we have the dividend written under the sign. In the left-hand side of it, you have the divisor, and it is what we now do that will lead to the quotient we have on top. Now, if you look at number 1, at step 1, we are asked to pick the first term of the dividend and divide it by the first term of the divisor. The first term of the dividend is 3x cubed. The first term of the divisor is x. So 3x cubed divided by x, it will give us 3x squared. That is the first step. You now write it on top of the dividend. You can see the 3x squared written there. After you have done that, you now multiply the divisor by that first term you have written up, 3x squared, and write it under the dividend. So x times 3x squared, it will give us 3x cubed. 3x squared times minus 2, it will give us the minus 6x squared that is written what? Here. So after that, you subtract 3x cubed minus 3x cubed, it will cancel out, minus 2x squared minus 6x squared. You know, minus times minus will give us plus. We now have minus 2x squared plus 6x squared, which will give us 4x squared. You bring out down the other terms, 5s and minus 7. So that is what gave us this, 4x squared plus 5s minus 7. Now you pick the first term again under the dividend, 4x squared, and divide it by x. It will give us 4x. And that is why you have plus 4x here. Plus 4x times s will give us 4x squared minus 4x times minus 2 will give us 8x. Again, you subtract. When you subtract, you are going to have 13x. You bring down the last term here, which is minus 7. That gives us 13x minus 7. Now, 13x divided by s will give us 13 plus 13. So you have 13x divided by s will give us 13. 13 times s will give us 13x. 13 times minus 2 will give us minus 26. You subtract 13s minus 13s will cancel out. Minus 7 minus 26. It becomes minus 7 plus, because we are going to have minus times minus giving us plus. So minus 7 plus 26, it will give us what? 19. So from this now, our dividend is 3x cubed minus 2x squared plus 5x minus 7. Our divisor is x minus 2. The quotient is 3x squared plus 4x plus 13, while the remainder is what? Is 19. So expressed in that form, P of x divided by Q of s equals to Q small letter x plus R of s divided by Q of s. We now have 3x cubed minus 2x squared plus 5s minus 7 divided by x minus 2. This is equals to 3x squared plus 4s plus 13 plus 19 divided by x over 2. So that is how we apply the method of long division. And method of long division is extensively used in polynomial. It's one of the methods that is mostly used in polynomial. We have the second example there. Divide the polynomial P of s equals to s raised to power 5 plus 4s raised to power 4 minus 3s plus 5 by Q of s, which is s raised to power 3 minus 2s plus 1, using the log division method. For my explanation, I believe you will understand what has been solved here on your own. If you follow the step very well, you have x raised to power 5 plus 4s raised to power 4 minus 3s plus 5 divided by x raised to power 3 minus 2s plus 1 equals to, the quotient will be s raised to power 2 plus 4s plus 2. The remainder will be 7s squared minus 3s plus 3 divided by x raised to power 3 minus 2x plus what? Plus 1. So now we have some practice questions there if you wish to go through it. But if you do, it will help you to understand the topic very well. Now we come to what we call the synthetic division. Under the synthetic division, the divisor Q of s must be a linear function of the form x minus c. and this and r of x must be equals to 0, or the degree of r of x is equals to what? 0. In the method, we usually arrive at a result of the form p of x divided by x minus c, which is equals to q of x plus r divided by x minus c. As we have procedures, steps followed in applying the long division method, we also have steps that will follow in using the synthetic division method. Now let's look at the steps in the process of synthetic division. 1. Since the divisor is of the form x minus c, we write c in a box and arrange on the same row 1 the coefficient of the dividend in the descending powers of x. Descending powers of x. That is from the one having the highest power to the one having the lowest power. And putting 0 coefficient for every missing value. What that one means is that if I have 2s cubed plus 2s plus 5, power of raised to x raised to power 2 is missing there. It means I'm going to put 0x raised to power 2 to make it a complete polynomial. Number 2, copying the leading coefficient of the dividend on the third row. Multiply the leading coefficient you copy by the number c in the box and write the result in the second row under the coefficient next to the leading coefficient and add the number in that column. Step 4, multiply the sum in 3 by the number c in the box and write the result in the second row next to the one obtained in step 3 and add the numbers in that column. Step 5, continue as in step 3 and step 4 until there is an entry on the third row for each entry in the first row. The last number in the third row is the remainder r, and the other number before the last r, the coefficient of the quotient. Now let's look at an example. Use synthetic division to obtain the quotient and the remainder when p of s is equals to 2x raised to power 4 minus 10x raised to power 2 minus 23x plus 6 is being divided by x minus 3. Now, as I have said, we'll put 3 outside. The coefficient of x raised to power 4 is 2. That is why you have 2, the first one there. The coefficient of x raised to power 3 is 0 because x raised to power 3 is missing. That is why we have 0. The coefficient of x squared is minus 10. The coefficient of x is minus 23. And the coefficient of the constant 6 is there. So when you follow the procedure, the number you have under it will be 6. The other one will be 18. The next one will be 24. And you have 3. So when you add, you have 2. You bring down 2. 0 plus 6 will give you 6. Minus 10 plus 18 will give you 8. Minus 23 plus 24 will give you 1. 6 plus 3 will give you what? 9. So in that case, 2x raised to power 4 minus 10x squared minus 23x plus 6 divided by x minus 3 will give you the quotient of 2x cubed plus 6x squared plus 8x plus 1. While the last one is what you have as your remainder, which is x and 9 all over x minus 3. There is another solve example there. You understand it. The c, value of c is minus 2. Now, how do we get that value of c? X plus 2, that is the divisor, equate it to 0. It will now give you, when you take that 2 to the other side, give you minus 2. That is how we get it to. X raised to power 4 has a coefficient 3. X raised to power 3 has a coefficient 8. X raised to power 2 has a coefficient minus 2. X raised to power 1 has a coefficient minus 10. And 4 is a constant. So that is how we have the first row. Following that step again, you are going to have minus 6, minus 4, 12, and minus 4. 3, you bring down your 3. 8 minus 6 will give you 2. Minus 2 plus minus 4 will give you minus 6. minus 10 plus 12 will give you 2, and 4 plus minus 4 will give you 0. In this case, the remainder is 0. So that is why we have 3s cubed plus 2s squared minus 6s plus 2 plus 0 all over x plus 2. So that is the procedure. You have some exercises under it that you can lay your hands on. Now, we'll look at the remainder theorem. Whenever we divide a polynomial p of s by x minus c, we always get some quotient q of s and the remainder r such that p of s is equals to x minus c q of s plus r. Now, if we set x to be equals to c in equation 1, we have p of c equals to r. If x is equals to c, it means you are going to have p of c x minus x or c minus c. That will give you 0. When multiplied by q of c, it will cancel out, which will only give you r on the right hand side. So from equation 2, we have that whenever p of s is divided by x minus c, the remainder is what? P of c. Whenever you divide a polynomial p of x by x minus c, the remainder is always p of c. We should take note of that. Now look at the first example under that. Find the value of k if the remainder when p of s is equals to 2s raised to power 4 plus k of x raised to power 3 minus 11s squared plus 4s plus 12 is divided by x minus 3 is 60. In this case now, we are given the remainder to be 60, the divisor to be x minus 3, and the dividend to be 2x raised to power 4 plus kx raised to power 3 minus 11x raised to power 2 plus 4x plus 12. Now let's come down to the solution. P of s is given there. P of 3, because our c now is 3, is 16. So if you substitute the value of p of x in the given polynomial, we have p of s equals to 2 bracket open 3 raised to power 4 plus k 3 raised to power 3 minus 11 3 raised to power 2 plus 4 bracket 3 plus 12. Now if you open this bracket and simplify, we are going to have 87 plus 27k. So 87 plus 27k will be equals to the remainder, which is what? 60. So taking 60 to the other side, you have 27k equals to 60 minus 87, which will give us 27k equals to minus 27. If you divide both sides by 27, you are going to have 27k divided by 27, which is equals to minus 27 divided by 27, which gives us that k equals to what? Minus what? 1. So the value of k is what? Minus 1. So in the given expression, p of s will be equals to 2x raised to power 4 minus x raised to power 3 minus 11s squared plus 4s plus 12. Now we'll come to example 2. Find the value of k for which the polynomial x raised to power 5 plus kx raised to power 4 minus 2s plus 1 leaves a remainder 5 when the dividend is what? X plus 2. So you follow the procedure, you arrive at k equals to what? 2. And that is how we got that what? K equals to 2. Now, example 3, a polynomial p of x equals to ax squared plus bs squared minus s plus 3 has a factor x plus 1, and when divided by x minus 4 leaves a remainder 12. Find the value of a and b and factorize p of s completely and also obtain its what? Zeros. So we have about 5 questions lumped together here. 1, we need to find the value of a and b. We need to find the factors of p of s, and we also need to obtain its what? 0. So let's go on now. we have the factor x plus 1. So if we compare that to x minus c, it means that c will be minus 1. And we are told that when that p of x that has the factor x plus 1, and when it is divided by x plus minus 4, leaves a remainder of 15. So for p of x minus 1, the remainder is 0. So you see from there, if you substitute the value of x equals to minus 1 in the polynomial, you are going to have minus a plus b equals to minus 4. That is equation 1. Now, if you substitute the value of s equals to 4, the remainder will be what? 15. So p of 4 will also give us 4a plus b equals to 1. So you have two equations which you need to solve simultaneously. You can either use the method of substitution or the method of elimination. But in any of the methods you use, you arrive at a equals to 1 and b is equals to what? Minus 3. You now substitute in the given polynomial, which will give us x squared, s cubed minus 3 s squared minus x plus 3. Now, if you factorize this, you have x minus 1, x plus 1, x plus 3. When you now equate this to 0, it will give us the zeros, which is s equals to 1, s is equals to minus 1, and s is equals to what? 3. So we will be stopping at this point. I want to let you know that by 3 p.m. today, there are questions that will be uploaded in your LMS. 2 assignments which I want you to solve. And I want to see it when we meet at Umuya on Monday by 9 a.m. Because 9 a.m. on Monday, we'll be meeting at Umuya for our Maths 101. So the 2 questions will be uploaded in your LMS. Solve them in 2 separate sheets and submit them to me that day. So I will call it a day at this point. Thank you all for attending the class. More importantly, don't forget to write your name and your department in the chat box because it will be used as your attendance. Thank you very much. That's all right. It was. I'm not Samia. I was thinking you are watching me over there now because the other day as I was rounding up.